It's not for the whole universe, it's for us.
Sorry, I just forgot to record.
That's okay.
Never
So,
mind.
so to me, that's what an ontology is in our context. But I'm not sure that for most building owners, it really matters what an ontology is. What they care about is what you do with it and why do I want to have one. And you mentioned another term, semantic information, which is also related to this. And so I think that's maybe the way to sort of begin to lay a little groundwork. There's lots of data available from buildings. Let's say I'm in a building, I get a piece of data from something and it's 72. Well, what does that mean? There's a whole lot of other information you need to interpret that. So one of the obvious things that you would like to have are units. Is it gallons per minute of a water flow someplace? Is it a pressure? Is it a temperature? Is it something else? So we can add units, and that's a kind of semantic information that helps us understand what the data means. But that's also not enough. Let's just say in my example that the 72 is in fact a temperature. Let's say it's degrees Fahrenheit. Okay, now I know it's a temperature, but temperature of what? Temperature of the air in a room, temperature of some air passing through a duct, temperature of water returning from a chiller loop, temperature of something in a cooling tower. So you need to know more than just it's a temperature and what the value is. You need to know where the measurement is being made and how that fits into the design of your building or your mechanical system in your building. So all that extra information is what we call the semantic information, and that's what we need in order to be able to interpret how to use this. If we want to deploy data analytical techniques or AI techniques, we have to be able to understand what data is available and what it means so that we can connect it to our tools. So that's what I would say is the base.
Open it up to the group.
So can I ask a question? Is it the intent to to make or provide more bigger profiles in ontology? Is it the intent to say, okay, this is what a VAV, and that's all the information that you would need in a standard format? Or is it just breaking it down really into the small individual parts?
I think the real intent is to try to enable you to deploy applications in a more cost-effective way. All this information that I described is already available in buildings, but where is it? It's in drawings, it's in the head of people who are involved in the maintenance of the building, it's in specifications for the control system and the way it's configured, and the computer can't find and interpret all those things. So if you want to hire someone to come into your building to deploy, let's say, a fault detection algorithm for looking for faults in certain kinds of equipment, they have to go through all this information and try to figure out what are the pieces they need to connect to their algorithm, their special sauce, in order for it to work. That's a very labor-intensive process. By creating these ontologies or these standards, we can hopefully reduce that labor to a very small amount. You're not paying an expert hours and hours of time to sift through this. A computer can find and at least suggest to the expert what are the right places to make these connections. So I think that's the real gain.
Steve, Jim Lee here. Thanks for joining us. If you start with BACnet as basically a baseline, providing a lot of those semantics to the industry over a period of time, how would you look forward and describe other metadata standards or ontology standards now? What are they bringing that BACnet did not bring? And take that forward into a discussion of where models of physical world systems come in, please.
Okay. Well, if we back up to the 1980s when what we call BACnet was being born, the big issue that a lot of building owners had was they couldn't buy products from different companies and connect them together and expect them to work because they use different communication protocols. So BACnet was really about trying to solve that problem, being able to have a common way to communicate so that you could buy and mix and match products from different companies. And I think it did that well. It did need to create a model of sorts in order to do that, and it used an object-oriented approach to do that. But for the kind of thing that I'm talking about the understanding what the data means from the various measurements, BACnet created a way to make human readable information using strings by naming conventions and descriptive fields. The problem with that approach is it's completely open-ended. And different people have different ideas about how they would make those descriptions and how they would do that naming. And even within a facility, some facilities turned out to be very rigorous about enforcing rules to their contractors about how to do that kind of naming and how to make those kinds of descriptions. And they verified that they did it when they did work in their facility. But a lot of building owners never did that. So what happened is different contractors come in at different times, they take a different approach, and now you've got this mix mash of various naming conventions and things that it takes a person even a lot of difficulty sometimes to figure it out. So BACnet gave some tools, but they were so free form that they weren't really rigorous enough to meet this particular need. The next thing that sort of came along to help deal with that I'm aware of was what's now called Project Haystack. They said, well, we can use strings, but let's constrain strings and let's call them tags. And so they started defining tags that hopefully were intuitive and people could use. And there's some benefit to that because now instead of a complete free form, now you're at least constraining the list of things that you're going to talk about. But it wasn't particularly rigorous, and people in different places interpreted them in different ways and made up different tags. So even if you could go into one facility and it could be hopefully consistent in that facility, it's not the same in a different facility. Some academics got involved and started to look at this, and they said, gee, this text-based tag thing is not really the way to go with our best technology. Well, let's use the things that are coming out of linked data and the internet. And they use a technology called resource description framework, which is mathematically a graph. So you can create these things and you can make a graph, and then there are already search tools that allow you to search the graph and do things. But they were looking for particular application needs, and they were working in buildings where they didn't have a ground truth on a lot of the information, and they created what we now know of as brick. It has a real usefulness, and it's great for a number of things, but it didn't get to the ground truth. So ASHRAE has been working for some time to develop a standard which is called Semantic Data Model for Analytics and Automation Applications in Buildings, which also, like brick, is based on using RDF. But the idea was, let's get the ground truth of the building. Let's represent the spaces that are in the building. Let's represent the mechanical equipment and how it's arranged. Let's identify the sensors and control points. Forget about what your application is. This is what's in the building, and this is how you can interpret the data. And the idea is you would use this to find what you need and to map to it with whatever model makes sense for your application. So that's been sort of the evolution that's been, driving the work that I've been involved with. Does that answer your question, Jim?
Thanks, Steve. Great.
Other thoughts?
Well, let me throw something else out there then, Anto. ASHRAE is not the only player in this game in the world. There are other ontologies and other semantic models being developed that are related to the building space. For example, a real estate core. They're very interested in commercial buildings that are rented and how do you represent spaces and things you need to know as a landlord for your tenants. And there are others. And one of the advantages of this technology that ASHRAE is using is you can take a model from a domain of one group and you can add to it another. So you can just continue to add information as long as you understand the ontology of the things that you're adding. You can connect them because they're graphs. So you just link more nodes in the graph and the graph becomes bigger. So one of the ideas is that you can have disparate development activities that can still potentially be linked together and become a whole in a facility where it makes sense for you to do that.
So does that addresses the sort of the purpose of the building? For example, if it is a hospital, presumably there are ontologies that describe hospital-ish things. So is the whole idea that these ontologies somehow plug into each other and relate to each other?
The idea is that they have the potential to do that, so that you can choose to do that if you wish, and you can develop tools that can understand how to bridge that together and how to interpret the data you can get. So that's the idea. It comes from the world of the internet. There's information scattered literally in computers all over the world, and there's this idea of linked data. How do I associate a piece of information in the computer in Australia with one that's in Canada, with another one that's in Ireland? And so this idea and the tools to do this really came from the data processing world, not from the building space.
So Steve, one of our theses here is that there's a lot of value to be unlocked in buildings. But that value is currently trapped in different silos, right? So a lot of the people on this call have been associated with building automation, HVAC control in those areas. And, the question is what if we could get into accounting data? Or what if we could get into HR data? Or what if we could get into environmental health and safety data? How can we correlate these things and make that work? So I'd be interested in finding out what we do with the ontologies that they already have in those areas, and what do we do in terms of presentation of our ontologies so that that the information is valuable from silo to silo.
Well, that's why in our ASHRAE effort, we turned to the work that came from the World Wide Web Consortium, the WC3, as the basis for the tools that we're using, because they're involved in a disparate area of technologies and interests. And so our hope is that these tools are general enough that we can do this linkage that I've talked about. But there is no one group that has the expertise in all those fields that you're talking about, Jim. So what we've done is we've taken a narrow piece of it. It's a little broader than HVAC because we've created ways to model, for example, your electricity distribution system in a building. So if you want to manage electrical loads because you have a smart grid application, for example, that you're trying to use, or you're trying to use some on-site renewable generation and you're trying to control that in certain critical places because of a power outage or some other reason. So we can do things like that, but we haven't looked at applications like hospitals and scheduling for universities or things of that sort. But the hope is that the technology, because it's graph-based and you can add things together, would permit that kind of expansion.
Right.
So, Steve, this is Steve Fay. What's the name again of the ASHRAE effort you have underway?
It's mostly known by its number, 223P, and 223.
Oh, it's 223P. Okay. All right.
And P means proposed.
Yep. And follow-up question on that is, as proposed, what's the time frame do you think something like that? Because I've watched the BACnet over the years. So what's your forecast for 223P becoming something that makes the marketplace?
I always laugh when people ask that question because if you know anything about the standards development process, you never know when it's going to end until you see the end.
Right.
But we've made a lot of progress.
Uh-huh.
I can tell you that we've been working for a few years already, and I believe we are going to be having the group who's doing the development work recommending a publication public review probably by the end of this month. And the review would not begin this month because there's a process that goes through an ASHRAE with going through editorial gates and so on. But I would anticipate sometime late spring there would be what's called a publication public review.
Okay.
So what have we already done? There was what was called an advisory public review a little over a year ago where we put it out for people and got comments. And we have, I don't have the exact number right in front of me. We had something like 650 issues that we've identified either through this public process or through things that have been brought up by members of our own group. And we've resolved all but 12 of them.
Wow. That's
why we think we're getting pretty close to something that's ready for a serious look as a really solid draft.
So from what you know, obviously it's been very focused on HVAC, I would think. But from what you know of the related OT applications or silos, if you will, lighting control, secure access control, video surveillance, parking lots, people tracking, how flexible or appropriate do you think 223P will be to those other verticals?
Everything you mentioned is included. We have lighting experts that are involved, so we're looking at how to model lighting systems. We have concepts of space that are defined in this draft standard that include outdoor spaces like patios and balconies and things of that sort. So we've done that. We have electrical distribution systems I mentioned. I forgot what else you said. Oh, access control. Yes, we have concepts for how to count people or identify whether a space is occupied or unoccupied.
Okay.
Access control in the physical security sort of sense is pretty lightly touched. We don't get into the details of how you decide to do access control, but you could, for example, model the locations of access control points meaning the things that you scan to get through a door or to log into something and how they're wired together, and you could do that kind of thing. But in terms of logic of how you do the access control, there's nothing related to that.
Yeah, that I don't know that that's necessary. What about video? That's a completely different animal.
The only way we really address video is there's ways to represent things like power over Ethernet or other kinds of communication cables, and you can put the network in and show where it is and where the various components of the network are, but nothing about what the data it conveys.
Okay.
Steve, there's, I guess the concern for a lot of people out there might be, we're seeing there's obviously Brick, there's DBO by Google, there's Haystack, so we've suddenly got a lot of things that are claiming, to be the answer for the ontology for the industry. You're coming along now and obviously presenting one with 223P. I mean, how does all this potentially gel together, or doesn't it?
It's a little messy, as you might think, and I think you'll get different views from different people. So I'm just going to give you my view.
Mm-hmm.
First of all, let me tell you something else I didn't mention about the 223 work. It's international in scope. We have people who are in our development team that are from multiple countries. All of our meetings are international, and it's also been linked to an ISO committee, which is the same committee that's the home for BACnet. So it's likely to be proposed as an ISO standard at the same time it's being finalized as an ASHRAE standard. So that gives it a lot of visibility. And there's a lot of support for it in Europe, particularly a European committee known as CEN-TC 247, which is the home of building standards in the European community. So it has that. But your question was more specific about how do we fit these different pieces together. So let me talk about that a little bit. One of the key people in development of Brick is one of our core models in our 223 effort. And he has far more expertise in Brick than I do. I hate to put him on the spot by naming him, but you might well know his name. And he tells me, he's an academic, and he tells me that he's convinced that you could algorithmically drive a Brick model from a 223 model. So if you have software that you've developed or tools that are expecting the Brick-like interface, assuming he's correct, you could run an algorithm and create a Brick model that allows you to use it as is to do what you would otherwise be doing if somebody had created it as a Brick model from start. So that's pretty good if that's true, and I can't prove that that's true. I have a lot of faith in this person, and I think it's likely to be true, or at least awfully close to true. When you start looking at a tag scheme like Haystack, that becomes a little bit more difficult because you're trying to map something which is very rigorously defined into something which is less rigorously defined, and who decides how that mapping actually works. I had proposed some time ago that we might consider including in the ASHRAE standard some Brick tags that we would define if you have a construct that we define rigorously and say, if you have this thing, and you want to use what we recommend as tags because you have a tag environment in the software you're deploying, use these particular tags for this thing. That turned out to be a big ask, and people sort of didn't want to go down that road. But the Brick world has done something like that. They've created some way to algorithmically generate, at least the academics claim they've done in some papers they published, generate a tag system. So what you could do potentially is do a conversion from a 223 model to a Brick model to a list of tags. But neither of those are what I think is the best approach. Because if I'm a company, I'm Acme, and I spent years to develop my magic tool. I have an internal model that I'm using to do my magic sauce that suits my needs. It's not going to be any of these things we've just talked about. It's going to be something that was different that they created. So you're going to have to map to that in some way. So to me, the real answer is you can write tools that could take a graph, a 223 graph, and generate queries to look for the things that are meaningful to you, and then assign them tags or assign them a Brick relationship. And so you can develop a library of these things so you don't have to throw away the software that you had. Some people think, gee, you're going to ask me to redevelop my software from scratch using this other model. I don't think that's necessary, and I don't think it's the right way to go about it. Somebody starting from scratch might do that, or they might not. It depends on how close the 223 model fits what their secret sauce is going to be. Does that help?
Yeah, kind of. It's just a shame that it kind of is not all been. I mean, things have been rolling for a while now, and we had Google going off and doing their thing, making it open source with GitHub and stuff, and it's just a tagging thing as well as the standards here. So would be nice if we could get some cooperation between all of the parties when we're looking at how we format data.
I agree, but it's difficult. We're doing what we can, and it won't be perfect. I can assure you that. But I think there's a different thing to think about here is that what's actually used in buildings? And the answer is almost none of these stuff is used in any building today. The big gain is the buildings that aren't doing anything, not the ones that have already started down one particular path. So you don't have to throw away something that's working in your building, but what we'd like to do is lower the entry cost so that we get many more people playing in the game. That's the real win.
Steve, Ken here. I just wondering, is anyone taking a look at this and poking at it with some of the new AI tools that are on the street? Because that probably has some ramification. AI likes structure, it likes decoding structure, and if in fact it can do that easily in the direction you're going. So it would seem to be useful to be doing some testing, I think, of AI tools, agentic stuff. Is there anything going on in that camp?
Very quietly, yes. Quietly, because it's a rapidly changing field and it's easy to make promises that might not be readily fulfilled. But I'll give you a specific example. I mentioned that there are tools that already exist to query these graph structures that come out of this resource description framework approach. One of the main tools that's used to do that is something called Sparkle, which is a query language that's been around for some time. And so I know that there are some people who have tried to use generative large language model AI tools to say, I want to find, and then make your list of what you want to find in a building and have it generate the Sparkle queries that then go and interrogate the graph to look what you're trying to find. And it looks promising. So I think there's some things like that that can help reduce the workload of tools that you're trying to build for deploying your application or learning about what's in your building. There also, I think, the potential for visualization tools that might be linked to AI. If you think about a building, there are thousands of what are typically called points in a large building. And these all become nodes and branches on your graph when you put all these relationships. And these graphs are quite large. It's very difficult for a person to look at a graph and interpret it. So I can imagine tools that can be used to find subgraphs, if you will, or portions of graphs that you can then visualize in ways that make it easy for a person to see the relationships and what's going on. So that's another place where I think there could be some really low-hanging fruit.
Steve, you talk about models of physical things and buildings and layouts and graphs. How does all this relate to building information modeling, industry foundation classes, or classical pieces of construction automation or architectural automation software leading into what we do?
That's a great question, Jim. One of the big decisions that we made when we started this was to try to not duplicate good work that had been done somewhere else that might attach to it. And BIM is a good example of that. That's very architectural in its design. It has a lot of details about the geometry of rooms, what walls are made of, where are windows and doorways and things of that sort. So in our work in 223, we decided we're not going to do any of that. We have a concept of a space, but a space has no geometry. It doesn't have a three-dimensional layout, and it doesn't have a three-dimensional coordinates in the building. It has a linkage to other spaces. But the idea was if you want to have all this geometric information and architectural information, then go to something like BIM. And in the BIM world, they long predated this development of RDF, but my understanding is that the BIM world is also looking at how to change from their historical work using Express to being able to represent the same kind of information in a graphic model that could be added to this. And that's, again, something that's happening in academia. I don't know of any products to do this, but I think there's a possibility of doing the integration of that kind in the future. But for the actual work, we said, we're not going to get into the architectural details. There's only two kinds of space. There's a physical space, which is something like a room or a hall or a corridor. Physical spaces can contain other physical spaces, like a floor of a building can contain a bunch of different rooms. And then there's a concept called a domain space. And a domain space means something to a control person. I have a place inside a physical space and I'm trying to keep the temperature and humidity controlled. So that would be an HVAC domain space. Inside that same physical space, I might have a lighting domain space or a physical access control domain space. So we make two kinds of spaces, these physical spaces and domain spaces, but they don't have geometry. The same thing applies to our mechanical equipment. The model can tell you that a particular air handler is upstream of a VAV box, but it doesn't tell you how far away it is or what the dimensions of the duct are or any of those kind of geometric things that matter if you're doing maintenance in the building or want to go repair something. We have to rely on something else for those kinds of details.
So over Zoom, I can already imagine Kimon having a big smile on his face. That's sort of demonstrated by a couple of comments that he made on chat. So that's great. Kimon and Steve, at some point you two are going to talk, but maybe not today. But I was going to, on BIM, so great stuff on BIM. I was going to ask Rick to comment from the C4SB perspective, because that's kind of another angle that's new in terms of another sort of, let's say, force in this industry.
Yeah, and assuming I'm not muted. Hi, Steve. I don't think we've actually met, but I actually think we're from the very same original hometown. But regardless of that, I'm the executive director of the C4SB, which is, as of I think what will be Friday, we are part of the Linux Foundation, and we're convening this Tiger team that I think you may have heard about. And as of this morning, I think we got enough commitments that the invitation actually went out, and that's scheduled to kick off on Friday. So there's several people from the 223 work that have agreed to participate, and Paris 2 is one of them, and I think Andrew Rogers has done a lot with the 223 committee as well, and some others. But we also have commitments from Brick, Rec, and Haystack, and so it was on call this morning with confirming the participation with some, obviously, the key people from Haystack. So that convening of these different ontology components.
Can you clarify the sort of the purpose of this group? What is the convening for?
So the convening is for, as Paris 2 is kind of laid out, and she's chairing it, really the agenda, which is to identify the different work that's been done, create a guide to the different sorts of knowledge graphs that exist from the different work, identify the sort of tooling that would be helpful for the creation of better software. And then with what we've got in terms of cooperation from the different entities, we're pretty confident that identifying how these overlaps or the gaps can be filled is going to be something that can actually be accomplished. And as now part of the Linux Foundation, we intend to create a working group that can help accelerate some of this work, the good work that's being done by ASHRAE, that's being done by other groups. We can just add a little bit of lighter fluid to the acceptance and to the then extension to other domains as well, because as you can imagine, and the question kind of came up, what's happening in other domains? And I mean, as you know, the Linux Foundation has a presence in automotive and a presence in architectural and construction and all kinds of other areas. And so we'll be able to leverage the work that is being done in other areas. So that we've kind of kept it a little bit under wraps that this Tiger team we hoped was going to be able to get launched, and with the reaction from and the acceptance of the invitation from almost everybody that we sent it out to, I think we can count on that convening being productive.
I'm aware of the Tiger team, Rick, and I got invited to be on it, but I declined only because I'm failing at being retired, but I'm doing the best I can. But I did suggest Paris 2 and a couple of the other folks, so I wish you well, and I think it's a great idea, and I'm all for it.
A couple of the key things that you mentioned about relative to the other domains, and BIM especially, and NGIS, and let them do their good work. Assume that RDF is at the core of what they're realizing they need to do, and then eventually either the extension or the mapping of the graphs to each other it just seems logical. I'm not a data scientist. I'm a convener.
Well, I didn't want to mislead anyone and think that I'm a BIM expert. I have sort of a kindergarten or maybe elementary school understanding of BIM and work with people who were BIM experts, but I'm not a deep BIM expert myself.
Tracy, you're part of this Tiger team. You want to chime in with your thoughts? You've been quiet so far.
Yeah, I've been thinking about all of this, and this has been a long journey, right? If you go back to the way that we were trying to address interoperability and intercommunication between subsystems over the years. And I was on the other side of the equation than a number of people here on the lawn side of things, and the approach taken there is differently. And we all started at the lower levels, and now we're coming up on this. So to me, this is kind of fascinating, and I'm really hopeful that all of this activity, the ASHRAE standard, the Tiger team, everything that's been going on is finally going to get us to a level of true interoperability that we've all imagined over the last couple of decades. I remember Jim and I talking, gosh, 20 years ago about BACnet and LAN and the direction, and I think it was pretty clear to us that it's like talking religion. They're both headed in the same direction, and they want the same outcome, just different approaches to this. So that is a good thing. But now today we find ourselves, I think, in a situation where we've had too many different approaches across different subsections and different applications within buildings. So trying to tie all of this together, really, I'm hopeful that we can actually get there from here, right? And we haven't, I don't think anyone has uttered the word AI here yet today, which is sort of the target of where some of this is headed, I think, and the importance of getting this right in order to really provide a better foundation for AI and what it will be able to do too. And I think we're going to talk about that more in the coming weeks here this month. But
Yeah, we
I'm kind of
talked
excited about this Tiger team thing and seeing what's going to happen, actually.
Yeah, we in our planning call last Wednesday, we talked about the AI topic in connection to ontology, and we probably will do that next week, kind of a thing, and just allocate the whole week to discuss that, because there's lots of different angles. You're right, we didn't really dig into that.
I mean, we got to get the ontology part of this right? Ontologies, when it comes to AI, part of the problem with AI and and we've heard this for years, ever since people have been talking about AI, is it trustworthy? Is it, it's only as good as, garbage in, garbage out. It's only as good as what you're providing it. And now we're getting a little bit more mature in that. And ontologies, to me, provide a certain level of traceability, and they answer why a model picked a particular solution, for instance. So I think that making sure that we get this right here as this feels very much like a critical transition point in controls and building automation to me, and getting this right here and not letting it splinter off too much again, I think is really critical in the work that's been going on here. So I'm anxious to see the final document out of ASHRAE actually too.
Let me make a couple of comments on your remarks, Tracy. First of all, I agree with what you're saying, and I do think it's going to be a long road, although things are going to be changing quickly. It seems like they change more quickly every year almost. We placed a bet in essence, and we're betting on that we picked a technology and a technology approach that has legs. Why did we pick it? We picked it because it didn't come from the building space. It's being driven by something much bigger, which is the worldwide connectivity that the internet represents. So we're betting that we can leverage all that work and what they've done and the tools they've already been developed to make it easier for the building space to go in this direction. That's one part of the bet. The other part of the bet is we don't have to build a model that represents everything. We can do one piece really well and let someone else do another piece really well. And we believe this will allow us to connect them together in ways that I described. So that helps to do the division, but in an additive way, meaning you can add other functionality that someone else did. So we're betting that that is a good approach. Time will tell, but I think it's a good bet. And lastly, there's another whole piece that nobody's mentioned here is where's the demand? You know, building owners don't understand the potential of this technology. They really don't. And they're driven by day-to-day problems that make it difficult for them to deploy it, even if they want to, because they're constrained in their budgets, they're constrained in the staff resources they have. So we're hoping that what we're doing will lower the entry cost to putting some of these new kinds of techniques and tools in place in buildings, and they can begin to see the economic benefit and the benefit on their maintenance staff. And if they see those benefits, then there will begin to be a drive from a marketing, from a buyer's standpoint to use the technology. So right now we're not quite there. It's not like the back in the days when people were screaming, we want to buy products from all these companies, and we want to do it 10 years ago. We don't have that yet of that kind of market pull, but I think we need that kind of market pull for it to really grow and flourish. So there's a bit of a chicken and an egg thing going here.
Yeah,
The
that's a
ma-
really important point too in this whole thing. We've talked about that a couple of times. And that's what makes this turning point feel a little different to me. It's one of those things where those who have enough knowledge understand the potential that this holds, but our customers don't understand to even ask for this for the most part, right? So it's a real problem. I meant to say hi, by the way, Steve. It's been a minute since we've talked.
It has.
Yeah, I was just thinking back. It's been a while. We do a lot of work in the restaurant industry, fast food in particular. And one of my frustrations have been, owners of restaurants are not technical people, but I'm on the technical side of their business. And right away, that creates a little bit of a barrier. They don't know enough to ask for what we provide, even though we know we can save them money. And, they tend to be focused on things that impact the menu, right? There's a saying in the industry, if you're not on the menu, if you don't impact that menu, you're really not that important to the industry, right? And this has a little bit of a feeling like that, and if Mark Peacock were here, he would say that too. He was always the guy to say, but are they asking for it? And what's the business case for all of this, right? So yeah.
Wondering, Rick, if you can comment to that, especially on some of the things that we've heard, people asking for things maybe shaped as a digital twin.
Yeah, I think that owners are asking for it, and that's why and they're asking for, why can't I see data from my buildings? And we're saying, well, here's the 72. What's your problem? But they are asking to be able to use AI on everything they do. And if they have a building, they're asking for AI to be able to be effective on their buildings. And we're saying, here's your 72. But owners are literally articulating that they want digital twins to be able to help make better decisions. And they're putting the digital twins across the parts of their business that they can. And you know where I'm going. And we're saying, here's your 72. And so as we get our act together, we can participate in what owners are doing in the rest of their business. And that's where, the examples of the restaurants, and I understand that the owner is saying, if it's not on the menu, I don't care, but they're using AI to figure out what to put on the menu. They're using AI to figure out, how does the weather impact what I sell on my menu? And so if we set up our buildings to be providing more than just here's your 72, then we will participate in the better decision making that they are asking for. And so I don't know how far behind we are, but we do hear from owners that, hey, we want to use AI on everything. And your industry is not making it easy because you're not doing things in a compatible way. You kind of got to BACnet and you congratulated yourself and stopped. I'm sorry. But but and it was a hell of an accomplishment.
But that's a good point. I hadn't really thought of it that way, that they are asking for it in disguise, right? Disguised as a request for effective AI.
Now,
And
yeah, now they can. Now they
we
have now they
can't,
understand what words to use to ask for it. Yeah.
and we can't get there unless we have, AI is to ontologies a little like Excel was to needing a PC back in the day, right? It's kind of the killer app of ontologies here. It is the thing that is going to create the demand and pull for all of this, and maybe force us all to finally get our acts together on how to really provide a solution for this. So I hadn't thought about it that way.
Do you agree with that, Steve?
I'm just delighted to hear these people saying that there's stuff going on out there that I don't see in myself, which is good, which is why you have multiple people. So I think the market pull is really important. So the fact that they see it beginning to happen, even though I haven't seen it, is really good.
Yeah, I think the way we were sort of talking about it is that they don't really know what to ask, but they kind of
But
know that there's something that they can have.
yeah, but even that is good.
Yeah.
So Steve, since
They're
I'm not
asking
sure,
questions, by the way. That's a good thing, right?
Yeah.
I'm not sure I understand how to explain 223 well enough. Could you give us a 2-minute elevator pitch on how you would explain 223? I mean, I think a lot of people here are fairly familiar with Haystack and certainly with ontology and semantics, but maybe not in particular with what 223 does. Could you give us a quick pitch there?
Well, I thought I did, but it essentially is meant to be a ground truth of the spatial arrangement of the building and the mechanical systems and equipment that you have in the building, the sensors that you have that you can tap into, and the places where you're taking control actions, all of which get represented mathematically in a graphical form so that you can use query languages to see what you're looking for. And the reason you want this is so that you can deploy at a lower the cost of deployment of tools. People keep saying AI. Well, AI is great, but it doesn't even have to be something you really think is artificial intelligence. It just needs to be something that needs the data, and that you can find the data that you need and you can map it to your tool so that it can do its job. That's the key purpose of it. It
So
doesn't constrain what the
is
purpose of.
223 a model? Would you describe it as a model?
Yes, I would. In the model are building blocks that you can use to create a building specific model. So it describes pieces of equipment, it describes connections, which are things like pipes and ducts. It describes sensors. It has a way to represent where the observation location of a sensor is, ways to describe the units that are being measured. You can get a value from because it's built into the model if it doesn't change, or you can get a value by getting a reference to a communication information to read it from a BACnet point or LAN point or anything else, so that you know how to form a message to go get the live data. Or it can.
What about physics or thermodynamics? Is that premeditated in the model, Steve?
Premeditated physics. I'm not quite sure I understand what that is.
No, I mean, if we are modeling these systems, the question is with respect to what is that model predicated on? I mean, you have to have a perspective on what you're going to do with the data when you build a model.
It's an attempt to be a ground truth on what's connected to what and where things are located in the building, but without geometry. And that may seem like a contradiction. But think about a process flow as a paradigm. I'm following the process flow of air or water or chilled water or refrigerant or whatever it is. The model can tell you all the different places along that flow path and what equipment you find, what sensors are there to measure things, how to get the value that sensor is reading now, or archival data for what it has read in the past, things of that sort. But it doesn't tell you the capacity of a chiller. It doesn't tell you you know, how long a pipe is. It just tells you there is one.
Yeah, but when you came up with that kind of model, you had to have use cases in mind as to what would be done with the model to think about it.
Yes, the use cases we thought about are things like digital twins, which came up in the conversation, automated fault detection and diagnostics, tools to help automate commissioning practices, energy analysis kinds of tools, things of that sort.
That's what I was fishing for. Super, thank you.
All right, so we need to wrap. We're past the top of the hour. So I think this has been a great conversation. Thank you very much, Steve. This has been.
I hope it was worth your while to spend all this time listening to me.
It was
Oh
great.
no,
It's great.
it was really great. We need to understand this. The industry needs to understand this. So we're going to continue this for the rest of this month, and you're welcome to come and join us or not as your availability allows. But otherwise, thank you for joining us, everybody. We'll get the video up on YouTube in the next couple of days, and have a great week, and bye-bye.
See you all next week.
Okay.
Bye-bye.
Thanks. Bye-bye.
Okay.